In Unit 4, Lesson 3.3, Disappearing Medicine, we're going to take a look at an exponential decay. The amount of medicine in the bloodstream of a patient decreases roughly exponentially, and then they provide us with a graph representing this function. An exponential function that models the medicine in the body of the patient T hours after an injection is given. So they give us two points to take a look at. So I always like to make a table of values. Your x-axis over here is time. So t, and this is hours after taking it. And then this is the amount of your y-axis over here is the amount of your medicine in the bloodstream, and they measured it by milligrams. So at 0, initial time of taking it, you've got 12 milligrams. And then what's time measured? Time is measured in hours. So 1 hour later, you've got 0.75 milligrams. I will say these are kind of funky numbers because whenever I take medicine, it's usually like one pill in a bottle is usually 250 milligrams. So I'm not really sure where they're coming up with the 12, but we'll just roll with it. Looking at number 1, use the graph to estimate 1/3. So we're looking between 0 and 1. So we want to find 1/3 of the distance between here on the x-axis. And we got to explain what does it tell us in this situation. Well, how many tick marks is this from here to here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How convenient. We want to find 1/3 of the way. So 1/3 of 12 is 4. So 1, 2, 3. So this is roughly 1/3 of the distance out. And if I go up to my table, we'll say it's a 4.8, 4.9, because it's really close to 5. And what does this mean? So if we're trying to find, I'll go ahead and write that value down first. 1/3 is about 4.8. And 1/3 is representing the x-axis. So it's 1/3 of an hour later. We have 4.8 milligrams of the medicine in the body. Now, a lot of times you don't hear us say, oh, 1/3 of the hour later, right? We talk about being like a half an hour later, but not really 1/3. So we're going to go ahead and I'm going to rewrite this a little bit and say that 1/3 of the hour later is 20 minutes, right? 1/3 of 60 minutes is an hour, so 1/3 of 60 is 20. So 20 minutes later, we have 4.8 milligrams of the medicine in the body. If we look at number 2, it says after 1 hour, there's 0.7 milligrams of medicine remains in the bloodstream. Find an equation that defines F. So remember, if this is exponential, we want to know what our starting amount is. And in this case, our starting amount is 12. And we want to know our growth factor. What do we multiply by? Right? So 12 times what? And you can even make a little equation. 12 times what number? Put a little question mark in there. Gave me my next, keep it color coded, gave me your next value in your table, right? So if we divide both sides by 12, right, or you take a 1y value and divide it by its previous amount, you'll always figure out your growth factor. So the answer to our question is whatever 0.75 divided by 12 is. Here we go, calculator. 0.75 divided by 12 is going to give me a growth factor of 0.0625. Remember the little trick math, enter. 1/16. So 0.0625 or 1/16. So our growth factor is 1/16 or 0.0625. So let's go ahead and write our equation. Y is equal to the initial amount of 12. We are decaying by a rate of 1/16 of the original amount each hour. And we're going to raise this to the T hours. Raise it to the T. Now, if you want to double check yourself, throw this into Desmos. Actually, you don't have to put Y. You can put F of T. And let's check our table of values. Come over here, go to Desmos. Let's go ahead and type it in there. Start graphing. Y is equal to 12. 1 divided by 16th. Get out there. There you go. Check our table. 0, 12, 1 is 0.75, and we did it. I'm just going to scale out that way just so you can see it way better. There you go.